Hello, friends. Welcome to video number 4 and your last video for Unit 1. So today we're going to be talking about the last of the referential collections we'll be studying, and that is the octatonic collection. Now, before we jump into what an octatonic collection is, I'd like to do a little bit of review by deriving the 3 collections that we have already studied. Now, if you remember from video lecture 1, way back in the beginning of the month, we talked about how the pentatonic collection can be derived by just taking a chunk of the circle of fifths. We talked about how you can just take 5 consecutive pitches from the circle of fifths and extract them, and that will be a pentatonic collection. In essence, then, if we were to transfer that over to our new circle, our clock face, what that's saying is you can start on any note. So I'm going to just start on pitch class 0, which is C. And if I accumulate perfect fifths, and by that I mean I'm just going to move clockwise by interval class 7, which is the equivalent to our perfect fifth. If I do that 4 times in a row to accumulate 5 pitches, I will eventually then have a pentatonic collection. So let's give it a try. I already got 1, so I went from 0 clockwise by interval class 7 to 7, and I'm going to do that 3 more times. Now, just to be sure, let's go ahead and put letter names on these. So pitch class 0 is C. We have D and E. Pitch class 7 is G. And 9 is A. Now, if you were to compare that to our handout from video lecture 1, you would find that this is indeed a pentatonic collection. Now, with the diatonic collection, I don't remember if I mentioned this in video 1, but the diatonic collection is actually derived in the same way. So we would accumulate perfect fifths, but we just keep going for 2 extra notes. So I'm going to reapply the same collection. And if you remember from the first step, the last note that I collected was pitch class 4. So I'm going to keep going now. So I moved by interval class 7 for 2 more notes. And now let's see what we ended up with. Now, this collection obviously isn't going to start on C per se. If we were to look at this with our 1 F sharp, we would say more than likely our reaction would be this is the G major collection. Now, this one's the easy one. Let's talk about the whole tone collection. We learned that last week you can derive either whole tone collection by just starting anywhere on the clock face and moving by interval class 2, which is the equivalent of a whole step. Now, all of these collections, pentatonic, diatonic, and whole tone, are derived by taking a single interval, either interval class 7 or interval class 2, and developing an entire collection from that one single interval. Today's collection is one that's generated not by 1 interval, but by 2. The octatonic collection can be generated by starting at any pitch on the clock face and alternating between 1 and 2 semitones, or alternating between half and whole steps. Now, when we do that, it turns out that the octatonic collection only has 3 possibilities. If you remember, the whole tone collection only has 2. The octatonic collection, because of that particular pattern, only has 3 possibilities. And we label them with these little subscripts, the same way we did with the whole tone collection, right? And the subscript tells us the lowest pitch classes that have the half step. So let's go ahead and, not on a clock face, but just in numbers, let's develop these 3 octatonic collections. So I'm going to start with octatonic 0, 1. So we've got 0 and 1. That's our +1. Now we are going to alternate between +1 and +2. So our next pitch is going to be moving by interval class 2. 1 + 2 gives us 3. And then we just keep alternating. And as you can see, if you do this correctly, you will land, after 8 distinct pitches, you will land back on your starting pitch at pitch number 9. And that's a great way to check yourself. If you land on another note for your 9th note, you know that your math somewhere is incorrect. So go ahead and derive the other 2 octatonic collections, Octatonic 1-2 and Octatonic 2-3, using that same pattern of +1 and +2. Okay, so hopefully we have the same answers. And as you can see, I completed the octave every time. So I do have a 9th integer for both of these. And that is just really genuinely to double check myself and make sure that everything is correct leading up to it, and that I complete the octave with the 9th note. Okay, let's go on to the second page. And what we have here is the opening of the piece that we're going to talk about in class on Wednesday. What I'd like you to do is go through and label each of the pitches, and it's pretty repetitive, but label each of the pitches with the pitch class integer that is appropriate. Please note that the second line is in alto clef and does have a different key signature than the top line. So label the PC integers and then come back and check your work. Okay, the biggest challenge, honestly, with this is just remembering that the E is sharp in the second system and labeling that appropriately. Now, let's take a kind of collective of all of the distinct pitch classes that we have here. I'm going to start with 0 just because it'll be easier for me to keep track of. Now, I ask, obviously, which octatonic collection Bartok has employed. By looking at the string of integers, it's really easy to see then that our lowest half step is 2 to 3, but let's also just double check and make sure that the collection is octatonic to begin with. So I am going to work through and label the intervals from note to note. So what you see is we do indeed have a chain of +2 and +1. And because our lowest half step is between pitch classes 2 and 3, we would label this collection as octatonic 2-3. Now, we haven't put the octatonic collection on a clock face yet. We're getting there, but we are going to take a pit stop with a different task. What I'd like you to do, we are going to together plot a fully diminished 7th chord on this first clock face. I'm going to arbitrarily choose my favorite one. And yes, I do have a favorite fully diminished 7th chord. And that is the one that begins on C sharp. So pitch class 1. And I'm going to plot this fully diminished 7th chord. So we've got C sharp, which is pitch class 1, E, which is PC 4, G, which is PC 7, and then B flat, which is PC 10. Now I am going to connect the dots. What I've ended up with is a square inside of my circle. Now, if you remember from likely theory 2, maybe theory 3, there are only 3 possible fully diminished 7th chords. They're symmetrically constructed, and there are only 3 possible variants in terms of pitch class. So what I'd like you to do is go ahead and plot the other 2 fully diminished 7th chords. hopefully we have the same squares in one order or the other for our other two fully diminished seventh chords. Now, that was not an arbitrary task. What I would like you to do now is choose any two of those fully diminished seventh chords and combine them in the clock face below. I'm going to arbitrarily choose the first two that I wrote, but you may choose two other ones and plot them on the clock face below. Okay, now what you have, if you drew the lines to make the squares, it probably looks pretty cool. I did not, but what we have here, you can tell just by looking at the construction on the clock face. We have a half step, interval class 1, followed by a whole step or IC2, and then a half step and a whole step all the way until we conclude with a whole step to bring us back to our starting point. In essence, we have plotted an octatonic collection. Now, if I asked you to label it, easy peasy, find the lowest half step. In this case, it is 0, 1. Now, the reason that I had us derive the collection in this particular way is to reinforce the idea that the octatonic collection consists of two fully diminished seventh chords kind of superimposed upon one another. Now, we have three possible fully diminished seventh chords, so it stands to reason that we would have three possible octatonic collections. We sort of exhaust the possible combinations of our fully diminished seventh chords. Now, this, of course, has tons of implications for the types of harmonies that you could build within the octatonic collection. You are obviously going to have a plethora of diminished sounds at your disposal, be it triads or seventh chords. And again, for my composing people who are thinking about their capstone projects, that's something to keep in mind in terms of the types of sounds that you can produce when you use this collection. There is a worksheet available for this lecture. If you would like to hand that in by Wednesday, it is up on Blackboard, and that'll be 5 points in the bank for you. You may also, if you would like, do a free write on this Bartok piece. It's called Song of the Harvest, and it is also available for you to free write by class on Wednesday. This is the piece we will be tackling. And I do want to make note that the octatonic collection has probably the most unusual to our kind of Western classical ears sound compared to the other collections we've listened to. Whole tone started to kind of push our boundaries. And the octatonic collection, I think, is going to kind of just bust out the boundary line entirely. So keep that in mind. It's a very different sound. And I'm really interested to hear kind of how it impacts you as a listener, and also just the kind of ideas you come up with by listening to this Bartok piece that employs that collection. All right. Thank you, guys. I look forward to seeing you on Wednesday.